So, good morning, Jarek.
Morning.
Morning. How are you today?
I'm great. And how are you? How is everybody?
Oh, we are so excited that we started the second day of the conference, and thank you so much for supporting our event and agreeing to give even 2 talks, not one, but 2 talks. So, what's the topic you are going to present now?
As the title is a transaction is a monad, and it's basically just the functional programming in enterprise applications.
Okay. Okay, the mic is yours, then please start.
Okay, so hello everybody. I hope you see my screen. So that's my talk. Transaction is a monad. And yeah, it's a really a pity I am not there in Kiev like last year. I really had a great time there. So yeah, but the time is as it is, 2020. Thank you for that. Not really, but yeah. So transaction is a monad. Well, but before I get into the details, a little bit of myself, very little. I live in Switzerland exactly, and right now here, yeah, again, I would rather be in Kiev, but yeah. And I'm software developer. I call myself sometimes wizard because this wizard is more for being a necromancer, keeping alive old system that should be already dead or actually are dead, but they don't know, but realized. And I call myself an architect. I work for Ingenious GmbH, a small company where we are doing stuff, consulting in banking and insurances and companies like that. Okay. My talk today will start with happiness. Okay. So why? Because as a developer, I like actually my job because it's a lot of fun. And for me, it's kind of like the same experience I had in the past with, I don't know, in a kindergarten when building castles of small blocks, designing, creation. That's a lot of joy. And I think most of you as developers have this, understand this pleasure. That's really a thing, yeah? That's why we like to spend so many hours in front of our computers. We like this pleasure. And then happens that you have this picture in mind, how great system you build. You put yet another block onto this, and everything starts to fall apart. Yeah, it just happens. Yeah, and then you get into the start race, which is longer than even the recent elections in USA, and you just go and you couldn't find where is this problem actually. Yeah, now the joy is slowly disappearing, evaporating. And then you even maybe see the reason of a problem, but it was like this: class cut exception, data source DT cannot be cast to data source DT. Oh, well, that's really helpful. Yeah. So, and we start to wonder, and we obviously sometimes the fixing of a problem is actually a challenge, and I don't know how many, but I actually love challenges. But not when there is too much. Not when every step I do, I get deeper into the swamp, and I go slower. That's what I don't really like. I think most of you don't like it. And I remember seeing the developers just talking. They would rather be septic tank cleaners or do some, I don't know, the real garbage collectors, yeah, on the streets than doing their job, because that's even now sounds nicer. How can it happen that such a wonderful job becomes a nightmare? So I still remember my good old times, my first Commodore 64 computer, when everything was so much simpler. I was really horrible developer at the time. Oh, come on, I was young, I was learning. But the things I was creating were way simpler. And the tools were horrible but simple. Everything was so easy to understand, like exactly like those blocks. So programs were short. Unfortunately, this world is gone. Even though we have better tools and we have better computers, the complexity of the things we build is unscalable, not comparable, harder, bigger. It's not even the same world as Commodore 64 or 80s or 90s. Yeah, we have tons of dependencies, layers, really complex domains. And you can no longer just do this, print a code, I don't know, on paper, and just go through this code and find a bug, which was sometimes really funny. And yeah, it's just not doable anymore. And the problem is, so how to not have these problems? How to not being forced to spend hours on debugging productive incidents? Yeah, that's the thing. Like most of people in our industry trying to solve. Like, what can we do with that? So, and constantly I hear from people that we just have to be more careful. And then I have this picture in mind, like developers in a lab carefully developing, this one line by line, yeah, everything like perfectly clean. How cool would that be? Yeah. And they say you have just to be careful. Yeah. It's just with every line you write. And I say, no, that's not the way. That's not actually what I want to do. Not that I like dirt so much. I just know the reality. And reality is that I know that, yeah, do I like it or not? Sometimes I write really critical code when I'm not fresh, because I was just fighting 12 hours with something else. And, then we have someone to help me or someone else with a review. But this guy was also like doing 10 big PRs in last 10 hours. So it doesn't really help. And then there are like testers that check if the code works on some test environment. Yeah. And because deadline is coming, then everything goes. Yeah. And then we have even tools. It's incredible how many companies have invested in tools like Sonar or other quality checking tools. And they completely ignore that those tools always show that everything is red and more red and even more red than that, like infrared. Yeah, it's just that like everyone got used to that. Because at the end you have the boss telling, yeah, exactly, that's the time, yeah, you have to concentrate on quality, yeah, because we have demo in 1 hour. Okay. So my idea, and like tons of people, is like, because the world is like it is, maybe we need to have better tools. Maybe we have to make a computer our reviewer. Maybe computer has to take more of these responsibilities, especially for repetitive tasks. And that's actually why functional programming is so popular now, because it solves some of this problem. Not all, but some of them. Because it helps with, for instance, local reasoning. What is a local reasoning? If you don't know this, it's basically, as a humans, we are very bad and juggling in mind with too many details. We want to have like a small amount of elements we are thinking about. So for instance, in this piece of the code that I am presenting now, we have some array list, which just add few elements to this, and then we calculate average at the end. And funny, on a production, the average was 10.5. If the local reasoning works, you know that the error must be in calc average function, because it takes some input, these values from array list, something must be broken there. So you get there, it's a simple code, and actually you realize, oh, it looks valid to me. And then you test it and it actually works as expected. So then you realize, oh my God, because this is a mutable list, and you just passed it to some other thread, which is sometimes randomly doing some changes and adding stuff, and now your local reasoning doesn't work. So in order to solve this problem now, instead of getting to one function, you have to go through like hundreds of lines of code, and your life is misery. We don't like it. So that's how many of us has learned to not mutate. And that's how in the past we learned other things that we shouldn't do. They work on a small scale, but when we have more and more complex problems to solve, they are horrible tools. And you cannot be just careful enough. That's, for instance, how most of us stopped using GoTo. I still remember this moment when when I read this article. That wasn't really original article, but something else in the press that Goto is a code small. And at that time I was basically basic and assembly coder. And okay, in assembly Goto is just jump. And I couldn't understand, like, how this is my basic building block. How can you even code without it? But then there was like even people saying, no, when you are careful, Goto is a cool thing. No, because you are not careful. You won't be careful. You won't be fresh always when you write the code. Don't use that. So the same thing later, I was like C programmer. I still remember that time. And I slowly learned that I need something like encapsulation, because I'm not always writing code when I can just carefully look at each line. I need some restrictions, constraints, encapsulation. That's how I get, how to say that? I was tricked to use object-oriented programming. I liked it. It worked for me for years. It still works, yeah, to some extent. Encapsulation and stuff like that. That's a cool thing. Although actually this is not only about object-oriented programming, but basically that was a lesson. You just don't manipulate everything. And then this is like, there were many things I learned to actually not do. But that's, let's say, recent years. Don't mutate. Because if you are careful, if you have time, it works. But if you do it on a scale, it's a problem. So last but not least, of course, we learned to do tests. And we have not unlearned yet to not write tests, but I will maybe address this. And tests are helping us. It's the additional job we do, but tests allow me to be less careful. That's a cool thing, actually. So in a JVM world, we are still way more lucky than JavaScript developers or PHP developers, because we have static types. We have type system that help us in not making stupid mistakes, like putting string where function expects integer and stuff like that. This is a cool thing, and we are so used to that in Java that we underestimate it. Typically, we have this encapsulation. Tests are popular, and that's what I see in code. Slowly, we use more and more immutability. For instance, a lot of Java developers switch to Kotlin, which allows you to make immutable classes easier, have some immutable collections. So some of Java developers switch to immutable collections from Vavr, really great library. And that's a huge progress I see. The problem is, now there is a next step to make. Because and that's a lot of my talks are about. We have fantastic frameworks that actually are a problem. Why they are a problem? They're partially trying to solve the same thing as functional programming. That we concentrate on a business logic, on less stuff, and a lot of infrastructure work is done behind. We don't see it, we just concentrate on business. The problem is the way the fantastic frameworks, mainstream frameworks in Java are done, because they use a lot of things from runtime magic, manipulation of classes, and this leads to strange problems. And yesterday there was a talk about it, for instance, on this conference about JPA. So let me present you, for instance, typical small problem in JPA. So you have this entity group, one-to-many users, then you have method get users. What can go wrong here? So you have another method, business method somewhere, that takes a group, this entity, then calls get users, then does something for these users. What can go wrong here? If you don't know, let me introduce you to something called lazy initialization exception. Now you probably remember this moment when you had this get users. Maybe no one called it before. Maybe it's lazy and I am now, after the transaction is finished, or I am even in a different thread, or someone called parallel stream. And some people say, oh, who would be that stupid to call parallel stream when you deal with JPA? Yeah, you know, it's like when our mainstream frameworks forbid us to use threads, then what they do in year 2020 when we have such nice tools. It's like something went wrong here, obviously. And I haven't even started on Jakarta or Spring. But basically all of these problems come from, the idea was good initially. Like the let's write clean business logic and have infrastructure in behind, don't care about it, make it automatically by a computer. The problem is it happens in a runtime in a very fragile way, and a way that it's hard to analyze. For instance, I love this. When you have two annotations like cached and secured on a method, what is actually first? First is caching or first is security? Because maybe the admin will log in and value he sees will be cached and displayed for all the other users. Yeah. And by the way, this you can find in documentations and in code what's actually the real order of this, but it takes a lot of effort. It's actually where local reasoning is broken. And every time you have some combinations like this and you start to wonder what is actually happening, you have a problem, because you have to rely. It's probably done in a correct way. If you want to check it, there is a lot of code to go through. That's basically a problem of leaking abstraction. Now the question that some of people state is, can we even code with all this runtime magic really on production and still be efficient? My answer is that we basically must. And the thing is that, now my trick, I was doing code in Scala before. I was doing even some code in Haskell, although in Haskell not really productive. And I realized in these worlds, you just don't use magic and still everything works. So Scala actually works on JVM. So why can't we use the same toys from Scala that are basically happening on a compilation level and reuse them in our Java or Kotlin projects? So, for instance, some people say, oh, you need a framework in order to just do simple REST services. That's how you actually write simple REST service without a framework. This is something I would rather call the library or a tool. So Javelin in that particular case, there are many of similar, just 2 lines of code, public static void main, no class path scanning, no magic, and you have REST service. Oh, this time very simple, but you can create as complex as you want with WebSockets and all that stuff that it's needed. And it works without magic, and it starts in a second or even less. Depends how fast it's your machine. This is really cool, and we have alternative frameworks. I'm glad I won't cover it today because I want to show some more abstract approach. It's the same with DB transactions. So I still remember this moment when it happens to me. I say that I don't use any major frameworks to control database transaction, and then everyone's reaction is, yo, so you write a lot of this code, and that like everyone thinks like I'm doing like connecting to database with a connection string, starting a statement like prepare statement, setting auto commit to false, blah blah. Then in case of exception, I'm doing rollback or commit. No, even 20 years ago when I first learned JDBC, I wasn't coding like that because I already was a developer, let's say with a couple of years of experience, almost 10. I knew that repeating the code is not a good idea, and even at Java 1.2, there was tools to solve this problem of repeating this code. Today, we can solve it even more efficient way because we have lambdas. So for instance, that's a thing that actually is coded in JOQ library, which I do love as an alternative to, for instance, JPA, because it's not leaking that much. I don't even see where it leaks. So basically it means that it's a really solid, stable, doesn't depend on any runtime magic. If you want to have a transaction, then I pass this lambda, which takes a database connection, does the stuff, returns a value. And there is a special method called transaction, which basically handles this lambda. It opens transaction for me, closes, does commit, and all that stuff. I don't have this code. I don't repeat this code. It's there in this function, which is function that takes a function that takes lambda, something we in Java world get used to with a starting of Java 8 with lambdas, but it's been there for a while. We can even do more next step, but if you have 2 functions, we can compose them and have other functions. I will show you in a minute how it works. Funny thing is that this was known in object-oriented programming as couple of design patterns like strategy, decorate, template, method. Nowadays, you can forget about these patterns, these particle ones. All of them are just instances. They are examples of higher order function that takes function. Why would you learn so many different ideas where all of them can be described by one more generic concept? That's it. So that's how cool it is. So for instance, you want a security. Then you create this function, secured, that takes a function from request to some t, and then has a second argument, a role that has to be checked. Then what I do, I simply get user from header and check if it has a role, and then finally I call the original function. But look at this, I don't really do it here. I return a function, so it's kind of a lazy now. I just say, if I am having this function that just does a business logic from request to t, I pack it and give you back a function that does this plus checking of security. And now this happens, let's say, with the help of a compiler without any magic. Yeah. So I have function that takes a function, returns another function. Because maybe I will have another thing that takes a function again that does something on a request and return t, and returns other function, but this time with caching. If the query strings are the same arguments, then I will use the pre-calculated value. For instance, here I'm, let's say, pretending that I'm using caffeine cache. Yeah, it would look like this. And then finally, if I'm building with this library like Javelin, my REST service, I just put here my code, and then instead of writing annotation, I just use function calls, cache and security. It returns me the function that actually has both of them, this security and cache. And I even see in which order, and it's easy to debug, and no magic is involved. And in case something fails, you can easily debug the stuff, because the problem, for instance, is not somewhere in bytecode manipulation, which is hard to really debug. And if you test it, you actually test the same code that runs on production. You maybe do that with a, I don't know, in-memory database or something. But it's a really cool thing. So the problem is, it's not a solution to everything. By the way, this is more my, let's say, level how I do stuff on production right now, and more or less people understand that. But not always we have this HTTP request in a context. And for instance, maybe you want to build something more generic, that we have a service like, and it has get user data, and now we just don't want to create a function that takes HTTP request something. I want to have this more generic. Then there may be a solution would be to create something like abstract user context, which would be like, or security context or something like that. And so that on a web layer, it would be HTTP request, on a service layer, it would be something which has just user inside, etc. That is an approach that works, and you can do that, people do that, but it has some limitation. There will be a moment when you build a bigger project, you will start to fight with compilation error, which, by the way, is still better than have runtime errors. So when compiler shows you an error, it's not your enemy. It's actually your friend saying you are trying to do something wrong. And I now stopped you, and I will help you present this error so that you don't put error on the production. It's really your friend. The problem is sometimes you are really, you have enough of these helpful messages that are sometimes a couple of screens long. You want to use something that doesn't involve so much thinking about types and function, etc. So funny thing is that this thing is called a monad. Yeah, that was a trap. This is the moment where I start to talk about monads. And I started with, because I assume that tons of you don't still know what a monad is. So this will be like now 5 minutes or maybe a little bit more about what a monad is, just by example. So you'll probably remember this piece of a code that you can find in the system: user service, get user from DB, user get group, group get owner, etc. And then send a message to the owner of group that user is doing something wrong. The problem is this code actually should be commented that on any step there is some implicit side effect, and maybe null, maybe exception, something can happen. So if you want to write this code in a secure way, you would have to do a lot of null checks, which is, by the way, completely stupid. Now the code is even more complex than at the beginning. So maybe it's now more secure, but oh, come on, you don't want to read this code. It's just it's messing the business logic with some infrastructure problems. So is the way, of course, you already should know it, that there is a way to that. We just rewrite original function, not get user from DB returning user, but returning optional of user. And we do that with all the other functions. So that's the typical code you get. After that, you just replace if with is present. And some people, I hope, yesterday there was a talk about it. It's not really that great. It's already better than it was before, because now the problem is explicit and compiler is helping you. Compiler is exactly now showing you where you need this if, or where if you consequently use optional, where you don't have to spoil your code with if checking, null checking, let's say. So this is a step better, but this is just not smart. In order to be smart, you must learn that optional has this operation map that allows you to manipulate the thing inside, and I hope most of you know. But actually the real operation is that you are looking for is not map, because map in that case will lead you to something like optional or optional group on a step 2, and then you would have optional of user, which would be really horrible to work with. So the solution for that is that there is a second method called flatMap that allows you to stay on one level of monad. So if when the map would lead to optional of optional something, you just use flatMap and you have just one level of optional. How cool it is, yeah? And then your code can look like this. And now all these if checks are actually now inside. This is an infrastructure now. The ifs are inside of optional code, but it's all there without magic. That's awesome. So optional is kind of a side effect, and I have shown you the power of monads. By the way, maybe you wanted to describe what can go wrong. Not that just user doesn't exist, but doesn't exist because, yeah? And nowadays, ton of people would use exceptions, but why not use other monad, this time called either? By the way, this is, for instance, included in a Wave package, which this monad has either user, the thing you want to, but in case the user doesn't exist, it shows what went wrong. By the way, you not only you can use it for errors, but basically that's typical use. So either your object or description what went wrong. Funny, if you do that, your code would look more or less the same. With the small difference that now at the end, here it's not in the code, but instead of try catch, you could basically check if that there was actually performed, but maybe there was error, and what kind of error was that, and display it. This is really cool. So formal definition of monad I will skip. That doesn't help at all if you are learning. Definition of by code is quite simple: flatMap, map, and off. So basically monad plus some loads. But we don't have enough time to discuss that. But if you see flatMap, that basically shows you, oh, you have a monad. Probably. It should behave correctly. By the way, not all monads in JDK, like optional, is a little bit broken, but we don't cover that. It's more or less good enough to be treated as monad. Now, what a monad is by comparison, like some people say metaphors are horrible, but I like this metaphor. I remember, if you are scared by monad word, M word, I was once scared by container word. That was at the time I was learning C++, and there was some idea of containers. At the end, it appeared to be quite simple. When I have list, vectors, sets, array list, whatever, those are all containers. So I have some type like a string, and then I have some container for this type. That's how I describe that, because I don't care how it's actually organized in memory, linked list, array list, whatever, or set. The important part is that is something above my type, and it's like multiplicity. So container is something like a type plus multiplicity effect. And by the way, it's exactly the containers are more or less monads, are monads, like listed as a monad. So a monad is just one step of abstraction above, a type plus some effect, not only multiplicity. So missing data like optional is a possible effect. Fail exception is an effect. Asynchronous computation, you remember, completable future is a monad. Multiplicity, so lists, streams especially, are monads. Transactions, I will show that. And even dependency injection can be written as a monad. Okay, but once we started into the theory, a little deviation. Now for, let's say, in a way, we go deeper. Maybe you've heard the word functor. And functor is something less than a monad. So something actually more generic, higher in the level of hierarchy. So functor is basically something that just has a map, doesn't need to have flat map. If it has flat map, this is a functor that is a monad. If it just has map, this is functor. Some people call it mappable. In reality, in programs I write in Java, Scala, or Kotlin, I don't really remember if I ever have functors that are not monads, but potentially there are such. Funny, that was an interesting thing. There is something between functor and monad, which is called applicative functor, which is crazy because, it's if functor is something that has a map and monad is something that has a flat map plus this map, what can be in the middle? So there is something, and this operation you can actually, this is probably the best idea to write it, which is called both. So if you have, for instance, two optionals, you can have one optional after this operation, which gives you pair of these things. Why it's important? Because applicative functor allows you to describe things that run parallelly. So for instance, if you have multiple HTTP calls that all of them are totally independent, you don't have to wait for one to start another, then you actually can code this HTTP call as an applicative functor, because maybe you start hundreds of them and at the end you want to get a list of 100 results, but you can parallelly call them. Maybe you have the same thing with database transactions, that you have transactions that do not really need to be dependent each one on another, but you just span hundreds transactions, each of them is independent, and at the end you have list of hundreds results. Maybe some of them even failed, but that's not your problem. You just wanted at the end the list of these results. So that's a thing you may, if you want to be practical and know a little bit about theory, if you have something that goes one by one, you chain it with a flat map, that's a monad, that's like serial computation one by one. The results from a previous step I need in a new step, then you are doing a monadic computation. If you can make it parallel, then it's applicative functor that you can use. And basically all the monads are also applicative functor, not always just very performant. So to the point of this talk, coding transaction as a monad is very simple. That's one of the many examples, and you can find some on the network. This actually is more or less from a system I built some time ago, coded in a Kotlin. So you have map operation, flat map, and pure. The important part that inside of this is some kind of a private property from handle to A. Handle is just the database connection, but as you would do it in JDBI. And JDBI is basically JDBC done in a proper way. So it's kind of a low-level framework. So I would say this is one step farther than what you use in JDBC template. Now you can code it in a smarter way. For instance, like this, select new job is transaction. Here is my, let's say, logic on a database, and then I flat map with a second transaction. And my code before was done in a way that both transactions actually will be joined, and the final code will be done in one database transaction, which, by the way, is not the only possible way to code that. But typically, most of the people would do that. If I wanted to span multiple transactions in parallel, not actually depending one on another, I would probably add this both operation to my transaction monad, but in reality, I never needed it. So, and the same can be done with other effects like security cache, diagnostic monitoring async. I won't cover this because I don't have that much time. And the world is really great. The problem is that you have a lot of flat maps now in your code. It would be better, and it is better if you don't code in Java or Kotlin, but you, for instance, have at least Scala, where flat mapping can be abstracted because you have something called functor comprehension, which is basically designed as do notation in Haskell, so I'd rather call it do notation, and parts of the problem are solved, but not all of them, not even in Scala. Because sometimes we have finally this future from secure, from transaction, from optional, from int. And then I have maybe that it's actually even lucky. What if then I have future of maybe optional of secure, etc. Sometimes flat mapping, combining this can be a challenge. And now we are more or less the same problem as with function composition. We are now fighting a compiler instead of doing our business logic, which again is better than having error on production, but uncool. So that's the problem of stacking monads. And this is one of the biggest problems that people actually are trying to solve. So there are solutions for that. One of the solutions is to use monad transformers. I won't get into this, but you may hear about it. Monad transformers basically allow you to manipulate your stack. For instance, you have future of int. You can now create future of option of int using option t monad. So if you have monad transformers, you can, in any place of code, lift, okay, there are different names for that, but you can actually fit your monads to, let's say, one common notation that you just needed in the piece of code so that you can use flat map. The problem is, first, monad transformers do not even work in Kotlin or Java. At least I don't know any sensible way because they need a little bit more sophisticated type system. And second, even in Scala, for instance, or even in Haskell, they are not that great at the end. Some people hate them with passion. I won't cover that because actually I never built any sensible system with monad transformer. I only experimented a little bit. Okay, and that's it. So what is an alternative? I don't know. There's for sure a name for that. I call it almighty monad. So maybe instead of having this future or something, maybe when I am designing a system as an architect or lead developer, I will start with writing just one monad, which has inside handling of all our things that we're gonna use, caching, JDBC, maybe HTTP, something like, put it all together in one monad and keep it. Even maybe use the optionality effect or stuff like that. It's doable, and people do that. It's like, say, kind of a my stack monad, and people even name it according to the stack they use. I don't know, maybe okay, C3. Okay, I've forgotten the correct final names. I've seen it, but basically, like if you use this stack, maybe vertex monad, whatever, then you just call it this way. Maybe reactive monad. By the way, Flux and Mono from Reactor are kind of this almighty monad, although that's a little bit different approach. So, and that's the way that works. But again, it's not funny because when you start the system, you would have to write this monad, and then you would have to care about it, and you have to maintain it. And maybe then you realize that you have three systems, each of them have very similar code, like this huge monad description for the system, and you just actually you would rather have it solved in one place. So there are alternative approaches, and I recently experimented with one in Kotlin, because there are, let's say, more or less ready solutions for Scala, but I wanted to use the concept from Scala, mostly from this extensible effect projects, like having the more or less the same things that this provides, or partially I was looking at the quite recently popular project Zio. And on the other hand, I wanted to make it as simple in use as Spring, which is, let's say, from completely different world. And that's how I created a crazy experiment, which is called Ni. And it looks like that. So that's your enterprise project now. you have annotations, and you don't know what is first, cache security or transactional, and you have manipulation of bytecode which fail with every new Java version. All that strange ideas can happen, and all that starts slow. And if something doesn't work with transactional, you have to get to where the framework starts and what's happening during the start of our application, that this transactional annotation is not visible, etc., etc. A lot of nightmares. But what if you write it like this? New, pure, effect secure, effect cache, effect transaction, and then your code. More or less, it's the same as before. And this is now a monad. This monad I just called ni, just the name, which basically has results. So each monad always has which type is there. At the end, I will have a list of users, user data, and then which kind of error can happen. This is additional parameter that can be posted. And that's my, let's say, environment. Partially, if you read about Z, you will see that I was heavily inspired by this project. So this is not a talk about monad, but I just wanted to show you an alternative that I create. By the way, this is now more or less experimental. What is ni? Ni is just a monad that inside has these small effects, and you can combine them easily, but flat map is written once. So it's like really a solution to a lot of problems, because you don't have so many errors, so many compilation problems, but you still have a lot of fun and advantages of using functional programming and monads. So there is this kind of a research project, and I stress research. Don't use it for production. It's used for fun only at the moment, and I don't even know if that is going to change. But maybe I'm presenting that because maybe someone will be in a company that they will have a lot of time to invest in similar solutions. And at the moment, I don't really know similar approaches in Kotlin, but at Scala, they are already, let's say, mature, and maybe someone will just create. Yeah. So I'm going to conclude this talk. So functional programming, basically we use to not be so stressed, to not be that careful, to have a compiler, especially this functional programming with a type system, to have a compiler that will check a lot of the potential errors that we can make. And there are some steps we do in that. Like first step, I hope everyone of you tries now, already tried, is immutability. This is a logical step, and it gives a lot. So if you start using immutable, for instance, structures and immutable collections, one day we'll get back to this old code with array lists, Java util, and you will realize how horrible now you are, because you see that it's not coding anymore. It's walking through the minefield. Everything can fail. You just don't want to do it anymore. Yeah. So that's how you actually accept that immutability is a natural way. Yeah, and that's a safe way. You feel safe when you don't mutate. Then the next step is forget about fantastic frameworks sometimes. Try higher order functions, because they are easier to test, easier to compose, and you rely on compiler, not on some magic bytecode manipulation and stuff in a runtime. Yeah, that can fail, that can work differently during tests and during production. I've seen multiple things that, for instance, force you to check more code than just the function that you are describing, like for instance in case of JPA. But when you go to this step, you will find a natural evolution of this. That next is learning about monads. It's not that you most of you now maybe use optional. That's a monad. But the thing is, like, when you are designing a system, you don't even think that's your architectural concept, a monad. But one day we will get there. And then you will get behind, like you learn that monad is one thing, applicative functor is something else, and functors, and you will compose projects in this way. Yeah. And that's our step. So, because at the end, the goal is simple. When I'm committing something on Friday, I shouldn't be afraid of putting that on production, because if it compiles, if it goes the basic tests, it shouldn't fail. It should not fail. Yeah. I should concentrate on business logic, and my tests should concentrate on testing that I implemented the rules as described by the business. But I shouldn't test if I am closing database connection. That should be provided by infrastructure. for instance, by monads. Finally, we'll have less occasions to the less possibilities to make bugs. And yeah, the compiler is kind of your reviewer. Sometimes you are angry on him because he shows you red messages, but that's his job, to point you where possibly is an error. And that's also important, exactly as I stressed. You will need less tests. You will need only those tests that describe like acceptance criteria, the business logic, not all this infrastructure stuff. That will be done once, maybe for your higher order functions or for your monads, and that's it. Not when you test do the invoices are summed correctly. Yeah, that's it. And that's probably, thank you, that's the end of my presentation, part one. And okay, part one, this is my presentation about monads. In 15 minutes, I think, I will go to the presentation about I will go even to assembly. So that will be a huge jump and deep dive into something completely else.
Thank you for so much, Jarek, for this talk. And yeah, you have the next talk on the next topic. So, dear participants, Jarek will join the Q&A Zoom room and will answer your questions after the second talk. We have some minutes left till the end of your slot. So, if anyone has any questions, just type them into the chat or connect to Q&A Zoom room and talk with Jarek after the second talk. Okay, thank you so much. We will see you in a couple minutes.